got an example of that here today, actually, with Rick Neff. Moving on. So Rick is with Cincinnati Incorporated. He's a sales manager of what's the BAM product, which is the Big Area Additive Manufacturing tool. It's a machinery manufacturer. Cincinnati's been around. I'm going to go off of this. So I've worked with Rick for a while. So I'm going to go through your bio.
That works.
Yeah. Cincinnati's a long-standing manufacturing tool equipment company in the heartland of the U.S., right? They've been around. They were building parts and press brakes and laser cutters for the entire manufacturing industry. Family-owned, medium-sized business, privately held company. Exactly that kind of company, though, that you said, where cash is important because family-owned. They want to need to make sure that whatever they do, they got to make payroll every week, that sort of thing. But they also wanted to innovate and saw this advances going on in additive manufacturing. Rick wound up coming down and working down at Oak Ridge National Labs. We have a manufacturing consortium down there around additive manufacturing where we connect the university and national lab resources around additive manufacturing is a nice word for 3D printing that's out there. And how do we push the state of the art of it? And they really, the researchers together brainstormed up and had a really outstanding idea to go with on that. And I'm going to let Rick take the story from there.
Thank you, Mark. I appreciate the introduction. I am going to use a crutch of using a PowerPoint presentation because that's what I'm just used to, being a sales guy. So, BAM. It's a lot of fun. We developed this product with some funding from the Department of Energy Advanced Manufacturing Office, working with Oak Ridge National Labs, America's largest national labs, manufacturing demonstration facility where they take some of the great technology that's developed in the lab and are moving it out into industry to help U.S. industry be more competitive. We make metal fabricating machinery and powdered metal compacting presses in Harrison, Ohio, just outside of Cincinnati, with our one manufacturing plant. We have about 400 employees, and we've been around since 1898. So long-term business, very cyclical business if you look at the machinery business. There are a number of different companies with Cincinnati in their name that make machinery. We don't want to get confused with the other ones, but we've been around for a while. We went down to the MDF and saw this blue gantry down there that was printing in ABS plastic with carbon fiber. And we thought that was pretty cool technology. And actually the technology was originated at Lockheed Martin. Kind of cool that we get to collaborate with a big company like that. But Lockheed Martin didn't want to build 3D printers, and neither did Oak Ridge National Labs. So we convinced them that we could take our standard laser product that looks like this when it's cutting a light gauge part, and this is real time. This is actually the part right here that we're cutting in the video, and you're welcome to come up and look at it afterwards. I think it'd be a little awkward to pass it around today. But we can position the gantry at 12,000 inches per minute, and we're cutting with a 4,000 watt fiber laser. Pretty exciting technology. So we sold Oak Ridge on the concept that we take the laser resonator and cutting head off, put a plastic extruder on the system, and we're 3D printing very quickly. So what we did is we signed a cooperative research and development agreement with Oak Ridge in February of 2014. Now, we're not used to doing business this way. When we develop a machine, we go hide in our tech center and spend about 3 years developing something before we talk to anybody about it. But what happened here is we had a press release saying we were going to develop a machine before we ever started. So we were putting the cart way before the horse. So we knew we had to go fast. So what did we do? A month later, we delivered a full-up motion system to Oak Ridge for them to turn into a 3D printer. And we're like, okay, we're not sure how fast these guys are going to do this. We've got a year-long CRADA. As it turns out, a little over a month later, they were printing good parts on this machine. So very exciting, very rapid technology. We wound up hooking up with this company, Local Motors, in the meantime. And Local Motors threw out a challenge. They said, we'd like to 3D print a car. And we'd like to print it in the next 6 months at a big trade show in Chicago. And we're like, this is crazy. We've never done anything like this before. But they went out to their design community, something they call co-creation, and solicited design ideas for a 3D printed car, of which they got over 200 really cool graphic designs. And we selected this car, Strati, to 3D print. And we came up with the graphics and selected it the first week of June of 2014. The first week of September 2014, we 3D printed the structure of the car at IMTS, the biggest machine tool trade show in North America, in front of the world. And that was really exciting. We then machined the structure so that we could have smooth areas that the design called for and also accurate points to attach the drivetrain and suspension. And we drove the Strati out of the show. Really exciting. Lots of fun, lots of press. We actually sold the first machine to Sabic, plastics company in Massachusetts. The second machine we sold to Local Motors, which they took on the road. We got invited, or at least Oak Ridge National Labs got invited to present some technology at the North American International Auto Show in January of 2015. And they were working on these kiosks to show off 3D printing and finishing and remote wireless charging, high-performance electric drives, metal printing, and they all of a sudden said, wait a minute, we're going to a car show. We should take a car. So on November 10th was the first day they said Cobra, and they built this 3D printed Shelby Cobra with a 100 kilowatt electric drive in it and had it at the car show on January 9th, so less than 2 months later. This looks a little rough as it was 3D printed, but our technology partner True Design finished it so that it was beautiful enough that it was used at the launch of one of the first innovation institutes, IACME, which is the Carbon Fiber Institute, or the Institute for Advanced Composite Manufacturing Innovation, IACME, and the president and the vice president were there. Exciting day, and the next day it showed up at the auto show in Detroit, where for the first morning everybody walked right by the car. We were really disappointed. We put a sign on it that said 3D printed car, and all of a sudden we got lots of attention. So it has become a celebrity since then. As a matter of fact, it went off to the climate talks in Paris at the request of the Secretary of Energy, and it's had quite its own celebrity status. We had another challenge that was thrown at us by the Assistant Secretary of Energy, Dave Danielson. He said, I'd like to do this project called AMI, which stands for Additive Manufacturing Integrated Energy. I'd like you to 3D print a house and a car. We're like, well, that's another big lift. But we got this opportunity to collaborate with all the companies you see on this slide. And the really cool thing about working with Oak Ridge is not just that we get to work with some of the smartest people in the world at Oak Ridge National Labs. It's that we get to work with all these different companies and collaborate with fantastic, really creative people. And if you really want to innovate, you take your point of view and someone else's point of view from a completely different part of the world and put them together and see what happens. And so we've been really able to accelerate innovation by collaboration, which I think is so important, something we couldn't do on our own. And so this is what it looked like when we 3D printed a house and a car. And the whole concept of this is when you're driving in your car, it makes about enough energy to power 2 homes. So why do we park that for 20-some hours a day? Let's use that asset. So the printed utility vehicle, or PUV as we call it, is a natural gas electric hybrid vehicle that can pull over a wireless charging pad and can run the electricity in the house from the natural gas generator in the PUV. The house, incidentally, can charge the batteries in the PUV from its solar cells or from the grid as well. A pretty exciting project. Had another project brought to us by the Army, and Adele Radcliffe over here. It was her project to 3D print a 1952 Jeep. And you go, why in the world would I want to 3D print the body for a 1952 Jeep? Well, it's really to go impress on the defense manufacturing community that they need to provide a really good digital thread with every product they're supplying to the government today. Now, it's really exciting that we've got this new technology, but any product that they're procuring today may only be procured for 2 years or 4 years, but the military needs to maintain it for 20 years. And if we don't know what manufacturing processes are going to be around to support it in 20 years, we can do a much better job if we've got a good digital thread for every product being supplied to the government today. And it came out looking beautiful as well. Could not tell it was a 3D printed Jeep unless you walked up to it and really looked at it closely. We also worked with Boeing on a trim tool for the 777X winglet, which folds up. It's a production tool in use today, and in September we got a Guinness World Record for having the largest 3D printed part to date. So that's pretty exciting. We also have worked on a collaboration with Boeing, Ford Motor Company, BASF, Tecmer, Oak Ridge, True Design, and others to work on high-temperature tooling applications for the aerospace market. This was the low-hanging fruit that Lockheed Martin saw to start with, was doing tooling for aerospace applications. And the blocking and tackling that hadn't been done along the way was developing the right materials. And so in working with Oak Ridge, we've been able to develop high-temperature materials like this material, which is a thermoplastic. It's PPS with carbon fiber in it, and it can survive in an autoclave at 350 degrees Fahrenheit with a carbon fiber composite part on it. Now, why is this important? When we're developing aircraft, we look at a prototype airplane today, a huge portion of the cost and the lead time is tied up in tooling. So if we can do tooling faster and less expensive, we can do prototype airplanes much faster and at much lower cost. We also have been doing some wind turbine blade molds at Oak Ridge. And also Oak Ridge has made a sealed delivery vehicle, which is an unpressurized submarine, which they did for Carderock Navy here just south of Washington, D.C. So pretty exciting stuff going on there as well. Now, what's really exciting is we've been able to, in a very short time, commercialize this, and we've got a great list of customers already, which I'd like to just acknowledge for half a second here. Textron Aviation in Wichita, Kansas is using this. Local Motors is a fantastic customer of ours. This is their Chandler microfactory, but they also have a microfactory right here at National Harbor. And David Wessner, who's over here, is the manager of that facility, and there's a 3D printer there if you'd like to see it. They also have one of the original Stratis in there if you'd like to see a 3D printed car. And one of their really other locations is Knoxville, Tennessee, where they intend to build this vehicle, which is Ollie. And Ollie is a 12-passenger autonomous vehicle. It's designed to be run in a limited space like a downtown sector of a city or an amusement park, and it works to pick up people and deliver them. You talk to IBM Watson. Again, IBM in your background, when you get on, instead of a driver, it can tell you where's a good restaurant to eat or what the weather's going to be like. Lockheed Martin in Marietta, Georgia is making tooling and fixturing with a BAM. Wichita State National Institute for Aviation Research is teaching aerospace companies how to use the technology. Additive Engineering Solutions in Akron, Ohio is doing Service Bureau work. And TSN near Monterrey, Mexico is doing communications vehicles. And lastly, University of Texas at El Paso has an America Makes project where we're going to embed conductors in 3D printed parts. That's very exciting. That starts up in March. So thank you very much. And again, it's been so much fun working with AMO. Really appreciate it.
Great. Thank you very much, Rick. That's a fascinating story. Just to remind people of the dates, it was less than 3 years ago when you just kicked off the idea. And at this point, you actually have an entire sector that you're moving forward on it. And a key thing in additive manufacturing is having the tool manufacturing, the equipment manufacturing companies, because that's the heart of the technology, and having that in the U.S. is a key element. Another thing that I find fascinating is when you look at it, the way you're able to accomplish what's gone on in this project is, first of all, the funds that were federal funds didn't go to Cincinnati. They went to the researchers at the National Lab working in partnership with the companies and the multiple companies that were doing it. But if you look at the research they were doing, they weren't just building a car. To make it go from one generation to the next, they had to do advanced computer modeling. They had to use things like a spallation neutron source to measure the residual stress inside of it so the thing didn't fall apart as it was being built. That sort of knowledge is what you can only have in an ecosystem where you bring your universities, your national labs together on all these